Welcome to chemistry class. The topic before us today is Introduction to Chemistry. I welcome you to this subject, an important aspect of the science subjects in your career. Chemistry can be defined as a branch of science which deals with the study of the nature, structure, properties, composition, and uses of all forms of matter, and the changes in structure which matter undergoes. From the definition, you can see that chemistry is an important aspect of science subjects. That's why I say what is how to do with a branch of science that deal with the study, the nature of matter, structure, that is what matter made up of, the property, physical and chemical, the composition, and which matter undergoes, and the changes which matter undergo. In order to study science or in general chemistry here, we have what referred to as scientific method. It's a series of steps developed in discovery of matter from what you observe until you get to law of principle. It's a step by step developed by science or by scientists in what discovery of matter starting from observation. That's number one. Scientists are very alert and inquisitive. That is, they want to know what's going on in the environment. So they use this sense to observe changes which happen around them. The organ of sight, the eye to see what has been happening for quite some time. They use their nose to perceive the odor. They use their tongue to taste, and the skin to know the change going on in the environment. After observing this with their five senses organ, it becomes a pattern. That is pattern coming from a set of observations which can become a certain pattern, can lead to a problem which they try to solve. That is, after you have observed certain things in your environment, in dealing with people, how to do with what you see every day. This can be something that can purge you to begin to look how you can solve the problem that might arise from that. From there, you have hypothesis. This is defined as reasonable explanation, which can be tested by experimentation. That is, you want to investigate. This is referred to as prediction or guesses which explain an observed problem. Hypothesis is how to do with what you predict, what you guess, and this can be explained experimentally. And from there, you go to what referred to as further experimentation. After your hypothesis, that will lead to experiment. Also, this will go to further experiment be carried out by other scientists in order to verify what you have put forward. And after you have done this, it can become a theory. A theory defined as the hypothesis that has been tested and found to be true within the limit of available evidence. Theory is the hypothesis that has been tested and found to be true within the limits of available evidence. And an example we can all refer to as Darting atomic theory. It's a theory proposed by Darting, a scientist, talking about the structure of atom. And after the theory, we have law of principle. When theory has been extensively tested and proven correct without any exception, it becomes a scientific law. And that's why we have different law in chemistry. For example, we can say we have thermodynamic law, or we have what referred to as a different law under different topic. Different law under different topic. In thermodynamics, we have law. In kinetic theory, we have different law proposed by different scientists. We have Boyle's law, we have Charles' law. A Boyle's law had to do with volume. So it states that volume of a given mass is proportional to the pressure, provided that the temperature remains constant. Now, why do we study chemistry? We study chemistry to acquire knowledge about matter. A scientist who studies chemistry is called chemist. We study chemistry to acquire knowledge about matter, what goes on around us, how to do with everyday life, and a scientist who studies chemistry is called chemist. Chemistry is applied in our everyday life as different activities take place in the environment, such as lighting a match. That is, when you want to cook, you use matches to light either your gas cooker, burn your firewood, rusting of iron. When you look at iron that become brown, that iron has been rotting. Rotting of wood or fruit. When your fruit become rotten, become smell. These are the examples or referred to as chemical processes. Chemical processes are processes that lead to change. You have new things being formed. What are the areas where you can apply chemistry? Number one, food. Chemistry is used to increase food production in the farm by use of fertilizer to increase the yield. You use insecticide to kill insects during planting, post-planting, even when you are storing your food stuff. Preservation of food, and you add essential nutrients to improve the quality of food in the area of food processing. Like you have so many factories that are dealing with food processing. You have Indomie, you have spaghetti. These are being processed food. Also in the area of clothing, you have textile fiber that are produced by chemical research. You have your clothing material being put together from cotton from the plant, put together to make textile material. And you have different color from dye, which also from the chemical industry to give you beautiful colors. Also, number three, housing. Before you have a building, you have cement, which is made from limestone. And when you mix cement and sand, you make your block or concrete, which you put together to make wall. After your building, you put roof on top of it from the aluminum roofing. You have tiles made from ceramics. These are the product of chemistry. After this, in the area of medical sciences, chemical research is employed in the production of drugs and medicine. All the drugs that we are using today to cure sicknesses and diseases, they are the product of several years of research from the plant extracts, which are being processed to become drugs, which are useful in the treatment of certain diseases. These are in the area of chemical research. You extract the plant extract, undergoing certain chemical processes, and from there it becomes drug that can be sold and people can get it to cure certain challenges in their body. The last one is on the transportation. We know that we need to move either body, goods from one place to another. This also we can apply chemistry. Just for example, the fuel that we use coming from the what we refer to as petroleum refining. Before you get your petrol, diesel, kerosene, Also, we have structural materials like alloy. Alloy are referred to as when you combine two or more metals. Alloy form when you combine two or more metals. All these alloy are light, strong, and they are resistant to heat. These are produced by chemical processes. Just for example, you have duralumin, you have brass, you have bronze, you have steel. These are the example of alloy. Also, we have adverse effect of chemistry. So whatever has good aspects, also we have certain aspects that we can look at. Adverse of chemistry, number one, we are referred to as environmental pollution. In those days when the scientific approach or method have not been developed, where we are living in the stone age, on the dark age, where there's no vehicle on the road, where there's no factory around, there's a limit to what we refer to as pollution. But because of development in the area of science, so we have chemical waste from various factories, and this has been a major challenge and causing problem for both human, animal, and even the environment. When they have chemical waste, that is the kind of waste from chemical industry. Just for example, where they are producing paint, they can have waste which they don't need again. This can be put into the water body and that can cause water pollution. Waste from refinery. During petroleum refinery, we have what referred to as waste products that is not good for their own use, but they throw it away carelessly, and this cause environmental pollution. Also, the smoke from the car, the smoke from the industry. We have the major challenge, oil spillage, where they are getting oil from. There can be a major error where the pipe is burst, or there's a major challenge and the oil begin to spill, and this leads to what referred to as major environmental pollution, which disturb the people's life there. It make their water to become unfit for drinking. It destroy their farmland, and so on and so forth. Also, we are referred to as drug abuse. Many hard drugs like heroin, cocaine, and morphine are additives, that is good one, that are used for medical treatment. But some bad people, they produce the drug, they sell it, and some consume it. Cocaine, heroin, morphine, they are part of good drug that can be used, just minute aspects in the production of drug, and give people their medical treatment. But when people are consuming this, people that are making gain out of the other people's sorrow, they sell this drug, they produce it, and they consume it, and this lead to serious health challenges and even problem in the society. So these are the adverse effects of chemistry. From So that's what we have on that topic. Now we have other aspect of chemistry. That is, when you want to study chemistry, you must know certain thing about the subject. We have a place called laboratory. Laboratory is a place where experiments are carried out. It can be a room, it can be a big hall, depending on the number of learners, where experiments are carried out for proper understanding of the subject. We have some laboratory apparatus and their uses. Number one, we have what referred to as evaporating dish. This made up of porcelain, which may be round or flat bottom in form of a glass apparatus. This is used in evaporation of solution to dryness. When you have solution and you want water to dry so that it can recover your solid during when you are separating mixture, you use what referred to evaporating dish. Number two is beaker, which is commonly used. You have beaker of different sizes. You have a flat bottom, cylindrical, and a graduated. You have a number there, usually a lip for easy pouring of solution. Beaker is used to hold solution or to measure solution during an experiment, particularly when you are doing titration. You put your acid in the beaker and you always label beaker A for acid and beaker B for base. Number three apparatus is the aspirator bottle. It looks like a jerry can in form of a container that make of plastic or glass, which is screw up tab, which is used for storing distilled water during an experiment. What is distilled water? Distilled water is a water that you are getting from distillation method. That is, it's a clean water that free of impurity. Number four, you are referred to as crucible, usually made of a porcelain also, with a little mud like a cover. It can withstand high temperature. Because of this, is used for a substance that you want to decompose. When you want a compound to decompose, laboratory, particularly chemistry, when you want to test what referred to as compound to decompose to give two or more smaller products, you use this crucible for that experiment. Also, we have waft bottle. It's a glass bottle used during production of dry gases. You want to prepare dry gases to hold liquid or solution that are employed as drying agents in absorbing unwanted gases. What are drying agents? Drying agents are used to dry gases. They are hygroscopic or deliquescent substances. What are hygroscopic substances? They are substances that when exposed to atmosphere, they absorb water without forming solution. And we have quite a number of examples of that. Examples are concentrated conc A2SO4, that is an acid. Also, we have other examples. What are the liquescent substances? They are substances when exposed to atmosphere, they absorb water and they form solution. Good example is sodium hydroxide. Sodium hydroxide is an example of deliquescent substances. We have calcium chloride, we have iron 2 chloride, etc. Also, we have another apparatus called conical flask. Conical flask is used during titration experiments, as I've explained. That's where you put your base. After you have prepared your base, that put in a conical flask. It also usually graduated. I need to estimate the volume of a solution. That is, you have a number there. Also, we have flat and round bottom flask. They are made of glass and they are mainly used for boiling, especially during distillation experiments. At the experiment, you to separate two liquids that can mix together, which we refer to as miscible liquid. E.g., when you have ethanol and water, you can separate these using this method. Another apparatus is called standard volumetric flask. Standard volumetric flask. It has a flat bottom, pear-shaped, with a narrow neck. It is used in preparing standard solution to specific or definite volume. What we call standard solution in chemistry laboratory is a solution whose concentration is known. That is, you know the mass of that per unit volume. That is in 1000 cm cube. That referred to as standard solution. Another apparatus is called foam cupboard, usually made of wooden cupboard with its front made of glass, which can easily move up and down. This is used to prepare poisonous gases like hydrogen sulfide and the rest. So the gases that are poisonous usually prepare using foam cupboard to prevent being inhaled and can cause dangerous health accidents. Another one is distillation flask. It has a flat or round bottom with a slanting long side arm and is used during the experiment called distillation, which I've explained earlier. Also, we have another apparatus called bell jar. It's made of thick glass, cylindrical, tall, and usually with a knob, something you can just control at the top, and used when you are carrying out combustion experiment. Combustion experiment. It had to do with uh, something burning or when something was exposed to oxygen. That referred to as combustion. Burning or something exposed to oxygen. For example, now carbon burn oxygen to produce two types of oxide, carbon 2 oxide and carbon 4 oxide. Also, we have gas jar, another apparatus called glass jar. It's made up of thick glass, cylindrical, that's the shape, tall and sealed at the bottom. It's used for the collection of gas over water or dry gas. Over water or dry gas. The next apparatus is called dropping bottle or dropping pipette. Dropping bottle or dropping pipette. This is used in keeping or transferring solution or reagent. This commonly used when you are doing traditional experiment and you want to apply your indicator. You use dropping pipette to apply indicator. You apply 2 or more drops. This is what we use during that experiment. We call it dropping pipette or dropping bottle to apply indicator to your base when you are carrying out traditional experiment. Another apparatus is called spatula. It looks like a spoon. It's an iron wood like a spoon. It's used in transferring little quantity of solid into the test tube. It looks like a spoon. It has a small top like a spoon used to take solid. Like now you want to carry out SWOT analysis, you take small sample with spatula and you put that into test tube or boiling tube. Also, we have another one is wire gauge. It's all made of iron mesh with asbestos placed at the tripod stand. Tripod stand having 3 legs, which you use when you want to carry out that you want to put something on high temperature, like what we have discussed before, like you want to a compound to decompose or you want to apply it to a particular experiment. Either you are testing for gas or you are testing for any of the cation or anion laboratory. Tripod stand having 3 legs, and we use Bunsen burner, the one you connect to your gas that will supply gas. From there you have your blue flame that you're going to supply your high temperature or heat. The next apparatus is referred to as retor stand with clamp. Generally used for support. Used for support, e.g. if for holding breath during titration, for holding breath, or also when you are doing titration, and also when you want to do something referred to as separation, like filtration now, this can be set. Use your retor stand with clamp to hold your test tube. You put your filter paper in your funnel and you put your dirty thing there to allow it to begin to drop. So it basically retor stand clamp used to hold. Also, we have mortar and pestle. It look like a mortar but small. They are made of porcelain using grinding or crushing solid into fine powder. When you have solid, the laboratory, and you want to turn it to powder, you use this to grind it. Basically, when you have solid, let's say you have a catalyst. A catalyst is a substance that one way or the other alter the rate of reaction but remain chemically unchanged at the end of the reaction. When your catalysts are in solid form, they perform less. When you grind them to be powder, you increase their surface area, and what you can use to grind them is mortar and pestle and some other solid that we need to convert to solid for them to work properly or work better. Also, we have what we refer separating funnel, which is one of the things I use to separate two immiscible liquid that cannot mix together. It is made up of glass, and when you want to separate mixture like kerosene and water, we use this apparatus. Also, oil and water, basically to separate immiscible liquid that are not mixed together. Also, we have Bunsen burner, which I've explained before, used to provide high temperature or heat, and by the combustion of liquefied propane or butane gas, the gas supply that will give you blue flame. Also, we have test tube holder. It's used to hold test tube in the laboratory. They can be made of wood or brass with a wooden handle. So that when you touch it, the conduction through the iron will not affect your hand. That's why made of wooden handle. They are used in holding test tube during experiment that require heating at high temperature. So these are the apparatus used in the laboratory, and these are some of the what I've talked about. If you look at this are what referred to as our dropping pipettes. This one is what referred to as Bunsen burner. The third one here that look like a three triangle is what referred to as triple stand. Here is our wire gauge. This is test tube holder. And now you can see this experiment or this setup. You have restore stand. You have the funnel here with a filter paper inside. You can call this setup that's a filtration experiment. The one here you have triple stand, the Bunsen burner, you have wire gauge on top, and you have crucible on top. When you want to heat any solid here, you put it on top here. So the setup here is for decomposing solid, where you have triple stand, you have the Bunsen burner, you have the wire gauge on top, and you have the crucible on top. And the last one you have here is what referred to as mortar and pestle. So we have come to the end of our teaching for now. God bless you.